All right, so looking at this one, what fraction is that? What fraction is shaded? What portion of the rectangle is shaded? 1/4 of it, huh? 1/4. All right. What fraction? So whenever you do a fraction, it's the part over the whole, as you know. Right? I'm not saying anything you don't already know. Fractions always mean part over whole. So on B, what part of the whole? How many are shaded? The shaded part is 2, right? Over, let me change there. So 2 over how many total? 8. 2/8, which you know is the same as 1/4. And these pictures are a good way to show equivalent fractions, aren't they? See how that's a model to show kids that 1/4 is equal to 2/8. Not just because your math teacher says so or because some kind of thing with numbers, just real life. You always want to appeal to people that you're teaching math to based on reality, not math tricks. Really, really, really. I mean, I think I probably said that before, but after 25 years of teaching and even seeing my own kiddos through homeschool come up the line, people that do well at math, it's real to them. It's real to them. The more you can help people to be real about it. So when they think of 2/8, what I mean by that? Well, instead of teaching kids, how do you reduce fractions? Well, you just look at 2/8 and you just say what number goes into both of them, and it's just one. I mean, you need to do that. I'm not saying you don't do that. You definitely teach them mechanics at some point. You got to be able to do mechanics. Absolutely true. But along with that, you would say, hey kids, what we're doing here is real life. It's not just some little thing. Let me show you. Look at those pictures. Isn't the same amount shaded? Isn't it? Yeah. And what's shaded here? 1/4. What's shaded there? 2/8. See how 1/4 and 2/8 are really the same thing? You want to appeal to that reality. Because that's what math is in the end. Well, math is made up, but it's made up to describe reality, isn't it? That's what math does. It just points to reality. So you don't want kids coming away from your math instruction thinking, you know what? This is just the math rule because Mr. or Mrs. such and such said so. They are the purveyor of all math knowledge. It just comes right out of their mouth. No, you want them to see math is about what's true. If I find something that's true, then math's going to say yeah. If it's false, math's going to say no. It's just about truth. Truth is the ultimate umpire when it comes to math. So you appeal to them in that by things like this. So look at C. So what portion is shaded? See how these are all the same? They're all the same portion of the rectangle. This one, what's the fraction going to be on that one? 3/12, which you know is the same. That one, 4/16. They're all 1/4, aren't they? They're all equivalent fractions, meaning they're the same. They're the same thing. What property of fractions? Oh, I guess I just said it a million times, huh? Equality of fractions. I'm not going to quiz you on those weird names. I think names are dumb. I mean, what's that? What does that do for your life? I can say this math word. That's useless. I don't. Anyway, so I'm not. You can count on me to not test you on names because that it does nation of logic, truth. For each of the following, write 3 fractions equal to the given fraction. Okay. So they want us to take 5/6 and write equivalent fractions. Another way to say the same thing. So if they want the denominator to be 30 in this case, and then we're going to go 48 and 54. So if I want it to be 30, you know what we need to do, right? We need to multiply top and bottom. You can use calculators for all this stuff. Rusty, you're talking about what times 6 is going to be 30? It's going to be 5, yeah. And you got to do the same thing on the top and the bottom. Why? Why do you have to do the same thing on the top and the bottom? Because Mr. Heron says so. No, that's not a good reason, right? Because otherwise you change the thing, huh? As long as you do same thing top and bottom, this fraction is really the same as that fraction, like the pictures we just saw. That's why we do that. That's why we do that in algebra, right? When you get higher up and they do higher level, algebra, pre-calculus, and they take fractions and they multiply top and bottom. It's all based on this. That if you do same thing top and bottom, you're not changing the fraction really. Those are the same amount, same portion. A fraction's a portion. All 4 of those, the same portion of the rectangle is shaded, huh? It's all 1/4, isn't it? Just different ways. And why is that? Because we multiplied top and bottom by 2. That's how we got 2/8. Or top and bottom by 3. That's how we got 3/12, right? So that's what we're demonstrating is the truth of that. That's what makes somebody good when they do calculus. On up to that level even. And I know probably most of you haven't taken calculus. But I'm saying it starts from those foundation levels. It really does. What you lay in them from those young years, I see them in calculus. And I see that fractions are real to them and make sense to them. So when I do a calculus thing over at City College, and I do some calculus thing, I can see they're dialed in. I do same thing top and bottom. That's the same fraction. They're dialed in or they're not. They learned at some point to just monkey see, monkey do math. And they don't really know what's going on. And then when they get higher up, there's too much monkey business. You're not going to make it in calculus if you have no sense of things. If all you do is imitate steps blindly, you're done. It's just not going to happen. It's just too messy at that point. You have to have a sense. And that sense comes from reality, that math is real and these things connect. Well, math isn't real. Math is made up to describe what's real. All right, how about the next one? What do we do times 6? It's going to make 48 there. Going to be 8. Yeah, just use your calculator. We can all be rusty on times tables. That doesn't matter. And then coming on down, what times 6 is 54? 9. Remember that one? Yeah. So we're just doing top and bottom. Whoops, and I'm doing it wrong. 5 times 9, 45. So we just made equivalent fractions. All right. Good. Okay. So 0/12. So what am I supposed to multiply the bottom by to make 60? Anybody know that one? 5? Good job. You just use calculator if you're not sure. 5, got to do the same thing top and bottom so we don't change it, right? What's 5 times 0? Guess what the next one's going to be? That's what they're all going to be. Yeah, because it doesn't matter what you do. If you're multiplying the top by 0, it's going to be 0. You catching that point? That's their point. 0 on the top is always 0. Doesn't matter what the bottom is, right? It's 0. If you say last night I ate 0/12 of the pie. Or pizza. I had a pizza. I did have some pizza. And it was cut into 12 pieces. I had 0/12. What is that? It's a weird way to say I had no pie. Or no pizza or whatever, right? But but I had 0/60. Oh, that's so different. That's still no pie or no pizza, right? You with me? 0 on the top just means 0, doesn't it? Doesn't matter what the... So if they give me a over 4, and they say make that something over a. So here's algebra, right? We bring in the letters. Whatever. Same idea. What do you got to do to the 4 to make it 8? 2. 2a. Good? What do you got to do to this next 4 to make it 40? 10, huh? 10a. You with me on that? That good? You good? I'll move on. Fine. Anyway, it's just funny just seeing that up close. The different ways we work. And that difference is what you want to lay in them is the really understanding what's happening. That is what enables people to go further. All right, 28 over 32. What do we do to reduce fractions? How does it work? What do we do? Yeah, whatever goes in, huh? Yeah, and you could do 2, but 4 is even better, huh? Because that'll reduce it quicker. So just 7/8. So that's the reduced. And that's because that's the same. If you had a big rectangle and you shaded 7/8 of it, that's the same thing as shading 7/32 of it. Or, sorry, 28/32 of it, isn't it? We good? So all that. What does it mean if you have 0 on the bottom? We talked about that. Like what would be like 3? Well, here, I want to be real with you about this. What if, I already did that. If I ate 1/3 of the pie, you know what that means, right? The pie was cut into 3 pieces, and I ate, let's say 2. See, I was really hungry. I ate 2/3 of the pie, right? The pie was cut into 3 whopping pieces. That's probably too much. Let's say the pie was cut into 6 pieces, and I had 1 of them. I ate 1/6 of the pie. That's more real life there. So what does it mean if I ate 0/6 of the pie? As we said, that's just 0. No big deal there, of course. Okay. Now, what do you think it means if you do it the other way and you put the 0 on the bottom? Try to be real with this.
You don't know if it's pie or pizza or anything.
Yeah, remember that bottom number is cut into, right? Cut into. And the top number is how many you ate. So the pie was cut into, or pizza or whatever, 0 pieces. and I eat 6 of them. That's crazy. That can't be. Are we out of time already? Oh. Cut into 0 pieces. How do you cut something into 0 pieces? Remember, if you don't touch the pie with a knife, it's 1 piece. It's not 0 pieces. If it was 0 pieces, it wouldn't be there, right? It's 1 big pie. So if you don't touch it, it's 1. If you cut it, now it's 2. Cut it again, it's 4, right? So how do you cut something into 0 pieces? That's impossible. So we say undefined. And what we mean is there's no connection in the real world for that. You can't do that. So that's different than 0 in the top, isn't it? All right, well, we're